All right, so I completed the soldering and I used my flux cleaner and I cleaned off the board. So you kind of see what our final result is. I'm pretty happy with it. We've got 60 solder joints here. That looks nice. And then if I flip it over to see the EEC-IV Ford connector, you kind of see the solder has made it all the way through. And yeah, so now I think I might put a screw here. I might put a short 440 screw. All right, so I kind of skipped a little bit ahead in time, but you see we've soldered on our 20 gauge wires to where it would have been the connector, you know, so we've got wires directly soldered there. And right now we have pin 25 on the V0.4 board, which is right at the tip of my finger there. That's the crank sensor input for a Hall. So this is our ARJU speed Druid, and we're outputting 60 RPM, and we're telling it it's an 8-1 crank tooth. And ignition 1, you see, is flashing away at a rate of tick, 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 tick. There you go. That would be 4 pulses a second, just like we were doing before. And I also have this. Or no, it's a 10 turn pot. Sorry, 10 turns of it will, and I believe it's a 50K is what it is. So I have one end of it going to ground, the other end of it. So there's multiple grounds on the ECU here. So the way you wire up these temp sensors, the coolant temp and air intake temp, is you have 2 leads. One of them goes to any ground on the board, and the other goes to obviously the coolant temp pin or the intake temp pin. So I've got the other one hooked up to, let's start turning the knob. Looks like I'm reading coolant temp right now. So as I turn this knob to the right, here, I'll do it on the same screen. There we go. Now I'm going to turn it to the left, and we're going down in temperature. There we go. So now I'm going to switch from our coolant temp to our air temp, which is the pin right now. So 19 and 20 are coolant temp and air temp. So there we go. So now our air temp is reading. So I'm going to turn this to the left, and air temp will come down. Turn it to the right, air temp should come up. Yes. Okay, so that's telling me that I think our ECU is working properly. If I suck on the I suck on the little map sensor here, it should, and then blow on a little bit. Yep. All right, so that proves that at least these 3 sensors and our RPM signal are working. There it goes. Now we're running again. Yeah, so the next thing I wanted to check was throttle position, and for that you need ground, 5 volts, and then a TPS pin. So I don't really have a throttle position sensor to play with, but we could play with that. But when I first hooked it up, it was freaking out, and I found it was dirty with flux, and I also found a couple of hair brushes from hairs from the flux brush. You know, some of these had they were bridging some gaps, so I think I was getting a few shorts. But yeah, it came out nice. I think it's I think we've kind of proven that our 0.4 board is operational. So the next thing I could do is hook up to 12 volts. So you see I've got 2 wires on our 12 volts, and that should start firing our injectors. Because right now we're just firing the 1 LED for channel 1. If I go in and change it to spark settings, wasted spark, burn, close. It's telling me I need to do a power cycle, so we'll power cycle it. Unplug. Plug it back in. Then we'll turn the lights off so you can see it. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. All right, so our ignition, or at least our ignition LEDs work. To check our fuel, we're gonna need to hook up 12 volts. So I guess maybe we'll do that next. All right, so I just have my jet ski battery just because I didn't feel like getting out the power supply. And you see we're still running at 60 RPM. And you see I switched it back to single output, just like it will be running in real life. But there you see 1, 2, 3, 4 injectors. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. Yep, okay, so that makes me happy. Seems like it's working. All our LEDs work, and all of our it seems as though all of our sensors are working properly. So I'm going to take the 12 volts out and turn the lights back on. And I guess the only thing I didn't check would have been the throttle position. So I guess I can work on that. But next what I want to do is start getting this to fit inside of here. Yeah, I'm happy with this. Initial testing is a success. The ECU has been fully assembled, and that was a lot of work. But now we've got 3 Speeduinos. We've got a NO2C, a V0.4, and then I got a V0.3 out on the Mustang. So pretty cool. Okay, so I guess now that we've fully built and assembled the Speeduino 0.4 board, and what I did is I have a can of this stuff. This is a flux remover, you know, so I was using the IPA and here's the flux we were using, the 186 Kester. So we had scrubbed it with a scrub brush and everything, and that worked pretty good. It was very tedious, but then I got a can of that flux remover and cleaned it up as best I could. And you see kind of what I've got here. So this is just a bundle of wires, and the goal is to solder the wires to our EEC-IV Ford connector, right? So here it says right here on our label, this is an EEC-IV style ECU, right? So this is the 60-pin Ford connector, and we need to solder on to these little stubs that I desoldered from the Ford factory board. So this is the Ford factory board, and just kind of showing a little size comparison. Pretty cool that we're basically replacing this board with this little board. And here's our Arduino Mega and everything. So the next step, now that we've kind of proven that our board is fully assembled, it's nice and clean. We'll put this to the side. We're not going to need that anymore. You know, it's fully assembled. It's nice and clean, and it does communicate with Tuner Studio. And so as far as I'm concerned, this is a fully assembled and functional V0.4 Speeduino board. Pretty neat. And now we're ready to resume the project of fitting it inside of our reworked Ford case. So in the interest of maximum height clearance, because here's our little cover, and if I put the cover on, let me get these power wires out the way. So this is basically our fully assembled form factor, you know. So if we just do a height comparison real quick, you can see that in theory this circuit card, even though we have some height added due to the Arduino Mega on the bottom there, and I guess if you were really looking to save height, you could desolder the USB connector and run wires, desolder that power jack. We're not using that because we're receiving power from here, but I think we'll be okay. So the goal is to get this height inside this case, and in that interest, what I did is I took two number 8 washers and put them between our sheet of FR4 and the Ford case here. And what that did is it lowered this down. So if I clip this into the case there, what I also, you know, you see I had 3 washers, but that was too much because that caused the bolt heads to interfere with this bottom piece. So I guess what I'm trying to tell you is I've lowered our mounting sheet two washer thicknesses down. So now we can kind of, and then what I also did is, if you notice, there's a little, wherever there's a threaded hole, there's a little bump out, there's a little bump out, there's a little bump out. You know, so 6 times, and what I did is I took my Dremel, I had my Dremel with my little stone bit, and I just ground out 6 little half rounds to clear that, and this now sits in there nice and flush. I'm happy with how that's going to work. So essentially this is what it'll look like in real life. So now we need to ensure that this height will clear in there, and obviously we have plenty of room to fit this thing in there. But now the question is, do we have the height? And you can see that if I put my camera, yeah, so we should have no problem now fitting it in there. So I'm happy with the height, and I don't care if these contacts are touching this, because this is a non-conductive sheet. This is a circuit board material. It's totally insulated from any electrical paths. So I'm thinking that I now need to secure this somewhere inside this case, and I'm thinking about using this screw hole, and then maybe that screw hole here. So we'll have 2 screws holding this thing where it needs to go. I want it to be a plug and play, full standalone ECU for any Ford Mustang years 86 through 95. This probably would work for the new edges too. But let's just do one thing at a time here. I'm thinking that the new edges are going to have, I think the new edges have a different connector, is my only reservation. I think the new edges have a connector like this. You see they changed the connector. This is off of a 2000 Ford Explorer, and you see how this connector is a little bit different than this socket. You know, it's not quite the same. So now we're trying to fit it into the case, and it looks like it's going to be a tighter fit than I thought it would be, but I think it'll fit. But I'm kind of showing an overhead view of where I think it's going to live, but I think we're going to have to cut this one off, you know. So I'll have 1, 2, 3, 4, 5, 6 screws holding the board in. I'm going to cut it, you know, flat with this face, and that will allow us to get the Speeduino all the way to the back. And then I think I might have to cut this angle piece off and maybe grind that one down a little bit, and that'll allow us to kind of tuck the board in that corner. Okay, so we did the 2 cuts. So there we cut that tab right off, and then we wanted some clearance on this tab. So, and now I think, I was looking at how am I going to connect this 60-pin Ford connector to the Speeduino wires, and I was looking at that. There's a breakout board for $40 that's available, but that looks like it would be too big. And plus, I kind of don't want to spend the $40. So I'm thinking what I might do is, it might be a little tedious, is you see that the pins just make a 90-degree bend. They come through here, and then they do a 90-degree bend up. And then they're kind of like melted in there. Okay, so you see we did the modification. So I cut that one off, and then I cut a little bit of an angle there. And then I also did a piece, you know, cut this piece out of there. So then I just screwed our board back in temporarily, and this is kind of what it's going to look like. All right, I think we got it. I got my tools everywhere because we're kind of right in the middle of this, but if you look, you see that I need to do some touching up. It's all still like rough cuts, but, and then I've got 1/2-inch tall spacers with a number 8 washer, just for, it worked out to be like 0.568 height. So now it's got like 0.550-ish. So we're getting a little bit of squeeze, which is good, you know. And then I got another one. There's a screw here, and then there's a screw here. So everything is loose. The last cut I have to do is I want to cut out the FR4 like to here. So maybe I'll take my Sharpie and we'll say cut across, you know, basically maybe a millimeter forward, you know, towards us of those pins. But yeah, here's the only thing I'm worried about now is, will our you see there's the 632 lock nut and flat washer, and this is a 632 by 1-inch screw, 2 of them, one there and one over here, right there. So yeah, so I'm just worried hopefully that lock nut doesn't hit. So yeah, that's the bottom. This is the cover, so that goes over everything, and then this is the main piece. So you see in there, that's our 1/2-inch spacer, which is this guy here. And then I put 2, just because it was a little bit more, it was, like I said, it was like 560, 570. I put 1 number 8 flat washer between the FR4 and the standoff. And then same thing over here. And then the screws are these, these 632 by 1-inch button head is what I did. And then that's that screw there. And that's, so then I have some number 6 flat washers, 2 of them, and number 6 lock nuts that I ground just a little bit, just so they're flush. And here's the 632 lock nuts, and then just some stainless, yeah, number 6 flat washers. So yeah, that's all like the hardware that I used. And so then, these bolts, I had 2 washers in there, but I took them out because before we were trying to get maximum height clearance, but that was causing our lock nuts here, this one and that one, to hit that face, you know. So by taking those 2 washers back out, it raised that face away. But then we still ground a little bit off, and now it clears perfectly. And we just are gonna make it with our height. The tallest component is this capacitor, and I kind of just pushed it a little bit, and we should clear. So now Now let me put it kind of together. The next thing, the only thing now that's left is I have to bend all these wires pretty much 90 within, you know, a 1/4 inch at the board or so. So I gotta make those bends pretty soon to come off and go that way. But now I'm torn what to do. I have available room here, you know, and I kind of want to go order that breakout board. Or now I'm thinking of, geez, can I just print my own? You know, if I ordered a PCB, I wonder if I should just get my own. Would that be cheaper? But I guess for 40 bucks, it's no. I guess that would be perfect, you know, because then I would just have to do loop, just do a loop for each wire, right end. I mean, that would be perfect if it fits. So maybe that would probably be the cleanest way. It would probably be the cleanest way, and then we would only be secured to the FR4 by these 4 screws, and then the 2 screws up here would secure the breakout board, I think. Maybe that would be the easiest way to do it. Maybe I could leave this open, or should I leave that open instead of put the plug in? But yeah, it's pretty neat that we're coming along with our Ford EEC-IV ECU that's running a Speeduino inside of it. So almost there. Looks pretty neat. If you can't tell, my parts came in, so it's been about the last time I talked to you was about maybe 2 weeks ago, but it took me a couple days of me doing my own research to figure out how to design one of a printed circuit board, a PCB, and I guess I just wanted to show you my final results. So it took from the time of placing the order, which was last Saturday. It took 1 full week plus 2 days. So what is that? That's 9 days to get to my house, which is absolutely fantastic. And you see what I designed here. All it is a little bit of a breakout board. So there is a breakout board available on eBay for $40. I think that was made by DIY Auto Tune or something like that. But that breakout board is a lot longer than this. And I needed to basically fit, you know, between here and that black line. So that would have been too big. Plus, part of me just didn't want to spend that 40 bucks. And part of me wanted to figure it out on my own, you know, kind of do more of a custom job. But basically, it was $6 and change for 5 of these boards. But the only kicker is you had to pay like 25 bucks for shipping. But I guess it came all the way from Hong Kong, China, you know, so 9 days from time of placing the order to my door is pretty impressive. And as you see, all it is a 60-pin breakout board. So this is a 2-layer PCB. So you see on the bottom of the PCB, we have only the middle row of our 60-pin EEC-IV EEC-IV Ford connector. So that the middle row goes to the middle row on the bottom of the board. But if I flip it over onto the top of the board, you see I have the inner and outer rows going to each other, and you can kind of just see the traces. This is a 1 ounce thick copper, 1 millimeter wide trace. And maybe later I'll show you the design files for this, but it's a simple, you know, basically 120 holes. There's 60 holes here that these wires are going to solder into, and then there's 60 holes here for the 60 pins. So all we have is basically a breakout board for the 60 pins, and it's almost perfect. I just used, you know, my calipers. I basically measured the Ford board here. This is just the stock, you know, factory Ford board, and I kind of measured this pattern as well as these 2 mounting holes, and it's pretty perfect. I had to drill out these 2 holes just a little bit. I had to go 2 drill sizes higher, so it's not perfect, but it's close enough for what I need. And my next step is to do the soldering. So you see the 60 pins are, I'm gonna need to do a little bit of touch up, but you see the 60 pins are poking through the board nice. So I think my next step is gonna be soldering. We're gonna solder this connector to the board. And then we're gonna have to do a little bit of trimming of this FR4 sheet. So of the 6 mounting holes we have, here they are. 2 of them are going to be to mount the connector and my custom printed circuit board, and then 4 of them are going to be to mount our FR4 sheet with the Speeduino 0.4 board. So basically, I just kind of wanted to show you my custom board that I designed. It's this is how it came. It came right from JLC PCB. It came just like this inside of a blue plastic bag that was, you know, sealed from the elements and everything. So I'm going to do some adjusting. I had to do a little bit of bending of the pins. My measurements were off by maybe, I don't know, 1/4 millimeter. So I had to push these pins in, and you see that some of them aren't fully, like this end is nice, but this end, some of them aren't fully through the board yet. So let me get out my soldering supplies. Well, plus we're not fully bottomed, so maybe that would help if I squeeze this. All right, so I'm already kind of started here. You've seen my solder setup, so I'm just gonna keep going. I've already done, I don't know, about 10 or 15 of these pins. So right now I'm just cleaning off my tip. I'm gonna tin the tip, and we're gonna kind of pick off where we left off. So can you see me? Yeah. All right, so we're just gonna kind of do a live solder demonstration. So I'm gonna kind of pick up here, and here we go. I already put some flux on all of these, so we're just gonna, I think that the problem is this solder is a little bit too small of diameter, but I got it for free, so beggars can't be choosers, right? So we got the flux on, and we're just kind of running down the line here. I did a couple to get started. I did like this one over here, and then I did one over here, just to kind of tack it in place, just like if we were going to be welding something. I want to tack the board so it doesn't, you know, flex or anything. And we're just doing 60 solder joints with our pine sill soldering iron. Okay, so now we're gonna, can you see? I'm gonna try and rotate you. It's hard with the camera here, but now we're gonna do these 30 over here. All right, now I'm gonna apply flux to these pins here. 1, 2, 3, 4, 10, 10, 10. Clean my tip. You can't see, but I'm doing it. You can hear it. All right, so tin the tip. And here we go. There's my tack. All right, I think we've successfully done it. So I'm gonna unplug our soldering iron, and we're gonna do a good cleaning. I'm gonna scrub this thing down and do a little bit of inspection. I'll catch up with you in a minute, but now we have all 60 pins nice and rigid now, nice and sturdy. All right, so I completed the soldering, and I used my flux cleaner, and I cleaned off the board. So you kind of see what our final result is. I'm pretty happy with it. We've got 60 solder joints here. That looks nice. And then if I flip it over to see the EEC-IV Ford connector, you kind of see the solder has made it all the way through. And yeah, so now I think I might put a screw here. I might put a short 440 screw. But our next step is this part also came in. So this is a 5/32 barb, a bulkhead fitting. So there's 5/32 nipples with a 6mm by 1 pitch thread. So what I'm going to do next is drill and tap right through, if I can, we're going to have the vacuum fitting be right here. So I want to carefully maybe measure and punch with my punch and drill and tap for this fitting. That way we'll be able to have the map sensor. Like I said, this is going to be plug and play plus the routing of a vacuum line to intake manifold vacuum after the throttle body. So between the throttle body and the heads. So next is that, and then it's going to be assembly. All right, so before I went ahead and installed the circuit board into our case here, I wanted to work on this bulkhead fitting for the map sensor, and my initial plan didn't quite work out. And I originally had just drilled a 6mm by 1 tapped hole. So here's a 6mm by 1 tap. If I flip it around so you can read it, that would help. There you go, M6 by 1. So, and that's what this thread is. And if you look, and I had it about there, you can see the problem. The barb isn't long enough. So then I came up with an idea. If I drill that hole larger and tap it with an 1/8 inch NPT tap, so this is an 1/8 inch NPT. So the vacuum line we're going to run is a 5/32 ID vacuum line. So now that vacuum line fits right through that hole. But now we need to adapt the 6mm to a 1/8 inch NPT. So this is a modified. I drilled and tapped on a lathe, so I drilled out an 1/8 inch NPT brass plug, and then I just used my bench grinder and I ground it shorter. So now basically the length of the fitting is as long as the threads. I'm going to thread this fitting into that fitting and then thread the two of them into that hole. So let me do that. All right, so I guess that's going to have to be as good as it's going to get. So we're going to thread our barb into our adapter. That threads in there real nice. And then now you see we have plenty of clearance for our 5/32 vacuum line to go to the map sensor. Okay, so now I think we're ready for final assembly. The only other thing is the USB port. The USB port. I'm wondering if ideally I'd like to put that here. So let me think about that. So there we go. So there's our custom breakout board installed. I've got the 2 screws on it. There we go. So now our breakout board is mounted. We have our map sensor line hooked up. Yeah, that looks pretty professional, I would say. So now you can kind of see how it's going to look in real life, right? So then this will feed over those wires, and there we go. Looks pretty good. So next I think we want to start reinstalling our FR4 sheet, which I think is, yeah, that's going to live in there. So let's kind of get going with that. But I did want to research. I did want to research a little bit on the USB. There is Bluetooth on this board, so there is a Bluetooth header. I have to fix that wire, it's damaged, but you see the Bluetooth header, BT for Bluetooth. So we could just have wireless, that would be kind of neat, but I would like to have the USB, you know, for uploading tunes and doing data logging and stuff like that. There's nothing like having a wired connection. Right now, like I said, I'm debating what to do with the USB cable. I think the next thing, I'm thinking of maybe running a USB Type-C, maybe. We could do that. That's kind of gaining popularity. Maybe bring the Mustang into 2025. Should we do that? That's a nice low profile connector. So I think my next step is to find maybe a USB Type B male to go into the Arduino to a female Type C port. Something like that I think I'm going to look for. And then we can maybe just take this cage, and it would be something maybe as simple as just filing with my half-round file, an oval, maybe. I don't know. Let's see.